Hey everyone! In this video, we are going to be looking at some lateral uniform acceleration over time problems. What this means is I'm going to try and move towards some problems where we're going sideways instead of dropping an egg off of a cliff or a rock down a well. So let's get started and see how that will work with a sled. So a sled begins sliding down a hill at 2 meters per second. It then experiences a uniform acceleration, that's the big flag there, of 0.1 meters per second squared for 30 seconds. How far did the sled travel? Now, I see a lot of students try this in different ways, but you can actually treat this like dropping a rock down a well, because we'll use the equation d equals 1 half at squared plus vit plus di. And when we fill this in, because we actually have all of the values that we need, we don't have to find an average velocity. We can just fill it right into this equation. So we can say d equals 1 half, our acceleration is 0.1 meters per second squared. That goes in. Make sure that our time, 30, is squared, plus our initial velocity, that's 2, multiply by the time again, that's the 30, and that initial position, we can actually fill that in as 0. We plug this into our calculator. We have everything that we need here. So d equals, we're going to do the first one. We'll do this in 2 steps just so everyone can see. Now, the 1 half times 0.1 times 30 squared is a 45. The 2 times 30 is a 60. Add those together. D equals 105 meters. We can do this without finding average velocities, without finding the time that the velocity increases, one step using this equation if we start thinking of falling as sideways, as long as we have that uniform acceleration. So let's go ahead and try another one here, except this time we have a truck going down a road. So a truck is driving 30 meters per second and then experiences a uniform acceleration of uniform acceleration, that's the flag, of negative 0.2 meters per second squared for 15 seconds. We have an initial velocity, we have an acceleration, we have a time. How far did the truck travel? If we had given you the final velocity instead of the acceleration, these problems are easier to find the average velocity. But since you weren't given the final velocity, you were just given the acceleration, it's actually quicker to do it in one step using this equation right here. D equals 1 half at squared plus vit plus di. So we can fill in our acceleration, negative 0.2. We fill in our 15 for time, so we have 15 squared, plus our velocity initial, which was 30, and we multiply that by our time again, and we add on our initial position, which is 0 unless the question somehow specifies otherwise. We can then go ahead, plug this into our calculator. We'll do it in 2 steps. We'll do that first whole chunk in the calculator, and we get negative 22.5. And then we do the 30 times 15, and we get plus 450. The 0 disappears. We add those together, and we get that the distance equals 427.5 meters. You can do this in one equation, one step, if you use this kinematics equation instead of trying to find the average velocity first. One step. I hope that this was helpful for you. Remember that this type of strategy is used anytime that you're given the acceleration, but not the final velocity. If you have any questions, please leave them in the comments below. Thanks for watching, and I'll be looking forward to seeing you next time.